In this problem, we have to deal with a function whose values are given by a table. So the speed of a racing car during the first 10 seconds of a race is given by this table below. Our task is to estimate the distance traveled during this time. So the speed at time t equals 0 is 0 meters per second. At t equals 1 second, the speed is 14 meters per second, and so forth. So the first thing that we may want to do is simply to plot this data to get an understanding of the speed. So here I have plotted the data. The red dots correspond to the values given by the table of the speed of the car. So we see that first the car accelerates very rapidly, then at time t equals 5 the car starts braking and brakes fiercely, and the speed goes down, so there's a corner, and then the car accelerates again. We may join the red dots by a line. This line, blue line, is now drawn by hand. It is an approximation of the speed of the car during the first 10 seconds of the race. The table was this one. The speed is given at times t equals 0, t equals 1, and so forth, up to t equals 10 seconds. And in order to estimate the distance traveled, we have to first compute average speeds. So time intervals are 1 second long, so delta of t is 1 second, and then v is the average velocity during the time interval. During the first time interval, the car speeds up from 0 meters per second to 14 meters per second. So the average velocity is 14 plus 0 divided by 2, that is 7 meters per second. During the next time interval, the car speeds up from 14 to 28 meters per second. The average velocity is 28 plus 14 divided by 2, and so forth. So the average velocities can be easily computed. They are averages of the speeds at the endpoints of these corresponding time intervals, and we get this table of the average speeds. First time interval, the average speed is 7, then 21, 35, and so forth. So this is just mechanical computation. So now we have computed time intervals and average speeds, and using this average velocity, it is easy to compute the distance traveled, or easy to estimate the distance traveled during that particular time interval. It is simply in numbers, it is the same, because speed is given by meters per second and the time interval is 1 second. So during the first time interval, the car travels 7 meters, during the second time interval 21, and so forth. So here we have the graph of the speed of this car, and the distance travel is speed times time, and the distance travel can be illustrated by these rectangles. So the distance traveled is also the same as the area of these rectangles shown here in this picture. And it's the total area of these red and blue rectangles, and this can easily be computed from this table. We simply add up these distances, we get 403 meters. So the average speed is 403 meters divided by 10 seconds, so it is 40.3 meters per second, which is approximately 90 miles per hour. So extremely fast. So the speed of an object at time t, if that is given by the function s, then the distance traveled during a time interval from a to b is the integral from a to b of s of t dt. So this is another application of integrations, and numerically we were able to estimate now this distance traveled. Here you see a photograph of a Red Bull Formula 1 racing car. its acceleration from 0 to 200 kilometers an hour, that is from 0 to 124 miles per hour, is 3.8 seconds. This is extraordinary. One cannot imagine what it feels to drive such a car. The acceleration is even more impressive. It's up to 5 to 6 G, that is 48 to 58 meters per second squared. They are unbelievable devices.